The actual is less than the allowable. Since it is, this is going to become okay, so beam shear is fine. Okay. Keep going. Okay, next, punching. This is a little bit different. Okay, this was beam. That's punching. Okay, punching. I don't know if you've ever had one of these, but if you've ever had that ice cream that comes in a thing that looks like a toilet paper roll and you got a stick on it and you push the ice cream up as you eat it, this is exactly what this is. I've got a concrete pedestal trying to push its way down through the concrete. And when it does it, it's going to try to take a cone out, and that cone is going to go right through here, just like that. Okay? So, we're going to try to push that through just like you do the stick through the cone, the cylinder to get the ice cream through. Okay, so let's read what it says. It says punching shear at a distance d/2 from the face of the pedestal. Now d/2, look at the line I've drawn. If you take a look at that, it's going out d. The average is in the middle, d/2. That's where the d/2 comes from. So let's take this and we're going to put a little box around here. And that's the punching, that's what we're trying to punch out. And it's d/2 bigger on each side. So 8.5 bigger on this side, 8.5 bigger on that side. I started out at 14. This looks like to be 31 inches by 31 inches is my plane of influence for punching shear. So you're going to need that. So let's continue. We're on punching shear. We're about there. It says find the force, X. This is the force. Okay, a little different. We're trying to push. In reality, what's trying to happen is the Earth is trying to push that cone or the foundation up past this little cone area. Okay, so I'm trying to lift this part right here. So you see I've cross-hatched everything except the green dashed area. So the force is the force trying to push that cross-hatched area around the green line. So if I look at that area, I want force is a pressure, which is 3657, times the area it's pushing on, and I'm going to do it kind of backwards. I'm going to take the area of the big square, and I'm going to subtract the area of the green square, and that'll leave me with the area of the cross-hatched. So 31 divided by 12 squared. So there's my force. This is the whole thing. This is the cross-hatched area when I subtract the green area. So this is the green area. And this is the whole area. So if I take the whole area and subtract the green area, I end up with the cross-hatched area. So let's do it. 31 divided by 12. 31 divided by 12, and I want to square that. And I want to subtract that from 8.75 squared. And then I want to multiply that by 3657. I end up with 255,584 pounds. So there's a quarter of 1,000,000 pounds of force pushing that piece of concrete up around that pedestal. Now, that's the actual. This is the allowable. Once again, it's property driven and size driven. So look at the equation. Y, 5EC, same as before. 0.75 times 4 times the square root of the concrete. Now, I want the area of the line, that green line. I want the area of it. So it looks like the perimeter times the depth will give me the area that I've got to bust. So perimeter is 4 times 31. The depth is D. If I multiply, so if you look at that equation and you try to figure it out a little bit, perimeter of the area that we're trying to bust, which is 4 times, and D is the 17. So let me do the math and we'll know what's resisting. 0.75 times 4 times the square root of 3,000 times 4 times 31 times 17. 380 pounds. Actual, allowable. Allowable is bigger than actual. Okay. So we've checked the concrete. So if you look at what I've done right here, this is all concrete. I've checked everything to make sure the concrete's not going to break. And it says it's not. So what do we got left? The steel. And on this one, the steel is the least intense part. So let's look at what it says. Now we're down to Z, compare the forces. What happens if they're reversed? What happens if the actual is bigger than the allowable? Obviously, I've got to do something. Looks like I can make it bigger. I can get better concrete. I can reduce the load. There's a lot of different options for that. Okay, that leaves us with one thing left. And that one thing is going to be steel. I'm going to get rid of this. I'll pull that in a little bit. And I'm going to letter AA. AA says determine the steel. AA. It says the area of the steel is equal to the moment. Where do I have it? Right here. I can pick either one. Doesn't matter. 3066917. 3066917 inch pounds. Moment divided by FY, and I had 40,000 pounds steel. And J, same as before, 0.9. And D, 17. Okay, when I get done, I'm going to have the number of square inches of steel required. So what's that mean? The area of these dots. It's going to tell me how much area I need in those dots. So if I take 3066917 divided by 40,000 divided by 0.9 divided by 17. 5.01 square inches. There's the area of steel. So, that's letter AA. This is the area of steel for the entire footer. Repeat the layout in the other direction. How do I go about getting the number of bars? I go back to page 416. I look up the area of a number 8 bar. So one number 8. So I'm going to go back to page 416. And I'm going to grab a number 8 bar. And it says here a number 8 bar is 1 inch diameter and has an area of 0.79 square inches. 1 inch diameter, 0.79 square inches of area. So the number is equal to 5.01, 0.79, divide the 2, and I should have myself the number of bars that I need. So 5.01, clear, 5.01 divided by 0.79 comes out to 6.34. Can't have a decimal. So I'm going to put 7 dots across there. So in reality, I'm going to end up with a mat, and the mat is going to be probably about 8 foot 2 and 2, about 8'5", 8'4" square, and it's going to have bars that crisscross. So I'll draw the mat in a second. Let's just run through it real quick and we're done. Dirt, non-factored loads. Subtract the weight of the footer. Use the net to figure the size by getting the area first, taking the square root, getting the width. Get your loads in order. Okay? Check resisting moment versus actual. Make sure you've got bending under control with concrete. Check the beam shear. Actual, allowable. Punching shear, actual, allowable. Now you've satisfied all the criteria for concrete. And then wander over there and take and put your moment you figured out before into the area equation. And this then is steel. And calculate the number of bars after you find the area by going to table on page 416. Grab out the data for the bar we're using, and we said we were going to use number 8 bars. Ends it up, I need 6.34. So my note here would be 7 number 8s each way. So the note on the drawing would be that, pointing to these bars, circle and straight. So 7 number 8s each way. So that takes care of that. Now all we got left is to draw a real quick picture, and this unit's over. And you are out of your book. So let me see. Here's what I've got. I've got a concrete 8 foot 9 inches square. Got a pedestal right in the middle of it, 14 inches square. And I want to put rebar in it. And I just figured I needed 7 of those guys. So I'm going to put 1 right down the center, 1 at the edge, 1 at the edge, and 2 in between. One down the center, 1 at the edge, 2 in between. So that would be the mat that was laying on the ground. These would be 1 inch diameter bars. There would be 7 of them equally spaced, and of course we're going to need at least 2 inches, maybe even 3. 2 men would be, unless we pour it against the dirt, then we need 3. So if it's 6 inches off of, so that cage would be 8 foot 3 inches by 8 foot 3 inches. You would set it in the hole. You would put bolsters underneath it to hold it up off the ground 3 inches. Pour concrete, screed it, and you're done. So that gets us actually out of your book. You're done with this textbook. You have 2 problems to do for homework associated with chapter 16. And I'm going to do something, number 16.2 B and 16.3 B. I'm going to give you some data so you've got it. If you do 16.2b, use H equals 15 inches and use number 5 bars. Okay? And if you're doing 16.3a, I'm going to get that data for you real quickly here. What are we using? We're using 500 and 4,000. 4,500. Like you to use 32 inches and number 10 bars. So there's your two problems associated with chapter 16. I'd like you to use that data right there. Once again, on a test, I will be giving this to you, so there's no use for you having to mess around and look it up. We've got one unit left, and that unit is form work. It's not in your text. The handout is chapter 4, 5, and 6. That handout has already been printed. It's, I believe, already loaded in files. If it's not there, I'll get it there. And you'll have to print it out and use it as a reference for lectures and for homework and for tests. So starting the next week then, or whenever this falls, the next Tuesday or Thursday, we'll end up starting there. I've got to explain the tables. So my progression is going to be explain the tables, which is chapter 4 and part of 5. Finish up loading, which is chapter 5, and then explain the two examples, wall form with struts and slab form work, and that's in chapter 6. By then we'll be at the end of the semester, and all we've got left is going to be the final exam. So I'll talk to you soon. Thank you.